Welcome to this Introduction to Wireless Hacking class. In this class, we're going to cover from A to Z the different wireless networks there are and how you can hack them. We're going to start by talking about the different types of wireless networks, including wireless A, B, G, N, and AC. We're going to talk about both spectrums, the 2.4 and 5 gigahertz spectrum. And then we're going to cover the different types of encryption used, both in WEP, WPA, and the latest WPA2 encryption methods. Finally, we're going to move into some practical pieces where we go through and actually crack WEP and WPA and WPA2 networks and show you how you can break that encryption and why wireless is an insecure medium for the most part. As we go through this course, you're going to learn not just the theory and book answers, but you're also going to learn some practical hands-on tips. We're going to use Kali Linux as our wireless hacking platform and use an Alpha Networks card that'll do packet injection so that we can go through and perform the attacks that we want on these live networks. Now, I know you're going to enjoy this class, so let's go ahead and move on and get started. The first thing we have to do before we can start hacking wireless networks is ensure that we have the right equipment. So the first piece of equipment that I want to use is what's called a wireless router, right, or a wireless access point. This is a standard one. I'm sure you have one laying around the house. Almost everyone does. This is an old one I used to have. It's called an N300. It's made by Netgear. You could pick these up for about $10 or $15 online on eBay or Amazon or something like that. The nice thing about this is it has a wireless B, wireless G, and wireless N modes. It also does support 2.4 gigahertz and 5 gigahertz modes. So I can set up a practice network, give it a password, and then try to attack it. Again, this is just going to be a standard wireless access point with a router combined. It does have 4 access points for your wired network, as well as the yellow one you see there, which is going to give us our internet access. In our case, we're probably not going to even hook it up to the internet because we just want a wireless network to be able to practice our hacking on. Now, the second thing you're going to need is you're going to need a network card that allows you to go into what's called promiscuous mode, as well as one that allows you to do packet injection. And so the one I actually like is this one right here, and you can see here, it is the 36NH. If you search for Alpha Networks 36NH on Amazon, you'll be able to find it. They run about $30 to $35, and they come with everything you need right in the box. They are a USB style network card. It plugs in with USB 2.0. The nice thing about these is they come with the 5 decibel antenna already attached, and you can plug these in and any Linux or OS X machine or even Windows will be able to run it without using drivers. So if you're using Kali Linux as your attack platform like we usually do in our courses, you plug this in and Kali's going to detect it right away when you boot it up. There's no need to mess with drivers or software, and we'll be able to use that with all of our Kali Linux wireless attack tools. The other thing that's really nice about this is if you have a signal that's too weak to be detected by this, you can actually take off this antenna, this 5 dB antenna, and you can swap it out with a 9 dB antenna. Now this runs about $5 to $10 on Amazon. Again, it's made by Alpha Networks. This one is called a N19 antenna, an ARS N19. And this is set up again for 2.4 gigahertz scale, so wireless B, G, or N. And it's going to give you 9 decibel of pickup, which is going to allow you to just screw it on, and now you have this long 18-inch, what my wife likes to call the magic wand, and it can actually pick up the signal from much further away. Now, if you're actually trying to do things from across the street or even further distances, one of the nice tricks that we can use is we can take a Pringles can, put it over the end of this, and it will actually directionalize this omnidirectional antenna to go one direction and pick up things from a much further range as well. So again, these are just some of the small little tools and techniques that I use as I build my wireless hacking network, and then I use the tools to actually exploit it. In this lesson, we're going to download and install VirtualBox. Now I'm doing this on a MacBook Pro, but if you're using Windows machine, it's going to be quite similar. Now first what you need to do is open up your web browser. I happen to use Google Chrome. And you're going to go to virtualbox.org. Once you get to VirtualBox, you're going to click on the download VirtualBox 5.1 and then select the operating system you have. If you're Windows, click Windows. I'm going to be using OS X, which is for Macintosh. And you'll notice it's going to start downloading. Now, once it's finished downloading, you're going to open it up from your Downloads folder. And I'm going to close my web browser so you can see easier. Now that the disk image is mounted, we're going to open up the virtualbox.pkg file, which is the installer file. Just do that by double-clicking it. If you're using Windows, you'll be double-clicking on your install or setup file. And then you'll run through the wizard. So in my case, I'm going to hit continue. I'm going to hit continue to go to the next screen. You can customize your installation if you wish. I like to leave my command line utilities installed as well, and then hit install. You'll be asked for your username or your administrator account. And then click install software. And it takes just about a minute for it to go through writing the files to your hard drive and installing it into your applications folder on Mac, or in Windows, your program files. And that's it. At that point, you can close the installer, move the installer to the trash, and at that point, it is installed. And if you go into your applications folder, you will see VirtualBox is there. Again, on Windows, you'll do this through your program files. In this lesson, we're going to download and install Kali Linux into our VirtualBox environment. To do that, we're going to open up our web browser first, in my case, Google Chrome. We are going to go to kali.org, Kali.org. Once you get there, you're going to click on the download button from the menu. And from downloads, we're going to go to download Kali Linux. From here, we're going to select the ISO, the Kali 64-bit ISO file, which is 2.6 gigabytes. So it may take a couple minutes depending on the speed of your internet connection. I'm going to pause the video here and speed up to when the download has finished at this point. All right, once Kali Linux ISO has downloaded, what we're going to do is close out our web browser, and we're going to open up VirtualBox. Now, from VirtualBox, we're going to hit New, and we're going to give it a name. I like to use the name Kali Linux because that's what we're installing. If you do that, you'll see automatically that it does recognize it is a Linux type. It is a 2.6 64-bit, which actually matches up with what we're going to be using. Next, we'll hit Continue. We're going to give it 2 gigabytes of RAM. On my system, I happen to have 16 gigabytes of RAM. If you're using only a 4 gigabyte system on your laptop, you may want to use only 1024 megabytes or 1 gigabyte of RAM. But because we're going to do some hacking, I like to have a little extra RAM available, so I'll use 2 gigabytes or 2048 megabytes, and then hit Continue. For your hard disk, what we're going to do is we are going to create a hard disk now, and hit Create, and we're going to use a VirtualBox disk image, and hit Continue. And we're going to dynamically allocate. What that means is it's not going to use up the entire amount of space on your hard drive right now. It'll only use it as it needs it. And then we'll hit Continue. Next, we're going to give it a size. And what I'm going to do is I'm going to give it 40 gigabytes to make sure I have plenty of space. And then I'll hit Create. And that hard disk has been virtually created. Now, for us to boot up the first time, what we're going to have to do is actually create what's called an optical drive by clicking here where it says Optical Drive Empty. And then choose disk image. And we're going to choose the ISO file that we had just downloaded, which for me happens to be in my downloads folder, and you'll see there it is, Kali Linux 2017.1-amd64.iso, which is 2.79 gigabytes, and we'll hit open. At this point, we're ready to launch and install Kali Linux. So we'll click on Kali once, and then hit start, and it will boot up, and what I will end up doing is I will select the graphical install. And now that we're in the graphical install, I'm going to choose my language, which is English, and hit Continue. I'm going to choose the United States where I live, and then I'm going to use American English for my keyboard. At this point, it's going to do some automatic configuration, mostly to do with our network, and then it will ask you what the host name is for your system. My host name, I'm just going to use Kali just to keep it easy. We'll hit Continue. And a domain name. For most of us, we're not going to have our own domain on our home network. So in this case, we can just skip it and leave it blank and hit Continue. Now we're going to set up our passwords. Kali by default likes to use root for the username because it is the root account, and they usually use Tor, T-O-O-R, for the password, which is root spelled backwards. In this case, that's what I'm going to use just to keep it easy for our lab. You can use whatever password you want to use, but for mine, that's what I'm going to use, and we'll hit Continue. You'll choose what configuration you have for your clock. In my case, I'm on the East Coast. I live by DC, so therefore I am the Eastern time zone. And now my hard disk is going to be configured. At this point, I want to use the entire disk and hit continue. And I will select the virtual hard disk we just created, that 40 gigabyte disk, and hit continue. And all the files in one partition will be fine. We'll hit continue, and then finish making the changes and hit continue. Do you want to write the changes to the disk? Yes, because we want to be able to install our software. Continue. And at this point, it's going to copy that 3 gigabyte-ish file of Kali over as it installs it onto the hard drive, that 40 gigabyte hard drive that we made. Again, this will take just a few moments. I'm going to speed up the video so you don't have to wait watching the progress bar creep to the right. At this point, it's going to ask, do you want to use a network mirror to be able to supplement the software that's on the CD-ROM? We're going to go ahead and say yes and hit continue. And if you have a proxy, which most of us don't at our home, we'll just hit continue. If you have a proxy, put it there. At this point, it's going to configure your package manager, and we'll get to the next part of the installation. And at this point, it's going to ask if you want to install the Grub bootloader. Go ahead and say yes, and then click on the hard drive you wish to install, which will be our SDA1, our VirtualBox hard drive, and hit continue. And at this point, it's just going to finish up your installation, and then it should boot to Kali Linux. At this point, hit continue. And when it reboots, you're going to be at the Grub bootloader. Just hit enter on Kali New Linux, and Kali will boot to its desktop. If your system asks to make configuration changes to the firewall to let VirtualBox out, I'm going to say yes because I want to be able to access the internet from my Kali box. Put in your root and your Tor for your password, and once you sign in, your desktop will show up. And your desktop should look like this, where you have the dragon showing up, and this is your standard Kali desktop. We're going to explore this more in the next lesson. At this point, we have installed VirtualBox and we have installed Kali Linux. The next thing we need to do is update our Kali Linux machine. And so the way we're going to do that is you can do it through the graphical environment or you can do it through the terminal. Now, I prefer to do it through the terminal, and I'm going to show you that because if you're going to start doing hacking, you really got to get comfortable with using the command prompt. So what we're going to do is we're going to click on the terminal, which is the second icon on the left. It has this little $ and the underscore, and it's called the terminal. So if you click on that, it'll load up, and you'll see this root at Kali, and then this # or hashtag as the young kids like to call it. And I'm just going to make this a little bit bigger so it'll be easier for everybody to see. And what we're going to do is we're going to do what's called apt-get, which is going to allow us to update our software. So what we're going to do is called apt-get, apt-get, and then put a space and then the word update. And when you hit enter, you are going to actually download any new packages since the VM was created. And so in this case, it's got the list of packages, but it hasn't installed them yet. Now, for us to go ahead and install that list of packages, we're going to type in apt-get and then the word upgrade, and then hit enter. And as you can see, you're going to get a lot of text, and it's going to say, do you want to continue? It's going to take 27 megabytes of disk space. Yes, I want all the latest software. So Y, enter. And it's going to go ahead, read the changes, download the software, and install it all for us. It's that easy to upgrade the system. So again, it's apt-get, and then do update. That gets you the list of what's changed, and then apt-get space upgrade, which is actually going to do the installation. I'm going to let this continue to run. It'll take a couple of minutes, and then we'll get back to the command prompt. So at this point, we're going to hit Q, and it's going to go on to the next install. Okay, and that's it. Your install has been completed with all of your updates, and you now have a good, clean Kali Linux box to work from. So the next thing I want us to do is I want us to shut down this box. So what we're going to do is we're going to close the terminal by clicking the X in the upper right corner. There's this little triangle in the upper right hand corner. If you click on that, you'll see what looks like a power button. Click on that and then click on power off. And what that's going to do is virtually shut down the machine that we were just dealing with. You can see it goes to a black screen. It's going to stop all the background processes. and then it's going to shut itself off, which is going to finish all of our installs for us and make sure that we're all done. So once Kali shuts down, you'll see in VirtualBox that you have this powered off Kali machine. So in this lecture, I'm going to show you how to connect that wireless USB Alpha Networks card to your virtual machine. So the first thing you need to do is open up your virtual machine manager by opening up VirtualBox. Now you'll see that I do have Kali Linux here, but I have no USB devices yet. So the first step is to connect this Alpha Networks wireless card to our computer. I'm hooking it up into my USB port, and then we're going to click on USB. Now from here, what we want to do is select the plus sign and then select the card we want. In our case, it's the Rawlink 802.11n WLAN wireless LAN card, which is the one that is made by Alpha Networks that we bought. And then we'll hit OK. So now you'll see that it has one device active. So once we have hooked up the USB Wi-Fi controller, what we're going to need to do is turn off the default network card that virtual machine uses. Now that one is, if we click on Network, you'll see that this has adapter number 1, and we're going to just check Enable Network Adapter and uncheck that box. What that does is it's going to unconnect what it thinks is a physical network connection to the internet, which is your normal Wi-Fi of your normal computer, or if you have a wired connection. At this point, we'll be able to launch the Kali Linux machine, and we'll only have one network card attached, which is going to be WLAN 0, or wireless network. Now, once we boot this thing up, we're going to go in, and we'll be at the desktop. And from here, we're going to ask to log in. Again, we're going to use root and Tor, or whichever password you chose during installation, and we'll get back up to our desktop. In this lesson, we're going to go ahead and set up a wireless network with WEP. You can use whatever wireless router you want to use. Now, the N300 that we're going to be using for our WPA and WPA2 experiments later on, it doesn't support WEP because it realizes how insecure WEP is as a standard. Luckily for us, my home router, my Verizon router, does have WEP as one of the options. So we're going to go ahead and log into that. Now, if you have a different router and you're not using Verizon, it may look a little different, but you'll have to follow the steps for your manufacturer to set up a WEP-based network, a wired equivalent privacy, and give it a random passkey. So the first thing I'm going to do is open up a web browser, and almost all of your wireless routers are going to be done this way, and you'll be going to the router address. On mine, it's 192.168.1.1, which is the default one for a Verizon router. And then you'll put in your username and your password. Once you've done that, click on Wireless Settings in the upper left corner, and you'll see here there's a Basic Security Settings tab on the left side. We'll click on that, and then we're going to turn on the 2.4 gigahertz wireless, which is going to be our BG or N network. And we're going to give it a new name. So in this case, we're going to call it Wireless Hacking, so we'll know later on which one we want to hack on. We'll let it choose the channel automatically, and we're going to set our encryption. And you'll notice here under 2.4 gigahertz security that we can select WEP or wired equivalent privacy. Now for WEP, we have to select a 10-digit password. So now we're going to go ahead and give it a password. So to give it a password, it has to be in hexadecimal format, which means it can be letters and numbers 0 through 9 and A through F. So you could see a simple hex password example up here. This is a longer one. It's going to allow us to put 10 digits. So we'll just start picking some digits at random here. How about 172583AEFA? That's perfectly fine. Now, anybody who wants to log onto the network is going to have to know that particular password when they go out. This is one of the reasons that WEP has fallen out of favor. Besides the fact that it's insecure, it's just that it has a very complicated number system that you have to use as a password. So you'll see here that these are our settings. We have it on. The name of the network is Wireless Hacking. Our password is 172583AEFA. It's going to choose a channel automatically. It is going to broadcast itself. It's not going to have any MAC authentication. We'll talk about that a little bit later. And it is going to operate on the N standard. So with that, we will hit Apply and hit OK, and then hit OK. So at this point, it will save our settings. It'll take usually about 60 seconds. At that point, we're going to see that the router will be ready to go, and we can close out of this web browser. And to see if that network is available, we'll click on our wireless icon, or on Windows, you'll go through your network neighborhood, and you'll see that wireless hacking is now enabled. Unfortunately, I don't remember what the password was that we chose, so we're going to have to hack into it because honestly, I don't remember, and we'd have to rewind the video to find out. So in the next lesson, we'll talk about hacking this web network. In this lecture, we're going to set up a WPA2 network so that we'll have something to hack against. Now, WPA2 is the latest encryption standard, as we've talked about before. This is the one you want to be using on your home network. The only way to really break WPA2 encryption is to guess the password using either a dictionary attack or a brute force attack. And we'll be doing that in our follow-up lessons. But before we can do that, we have to have a network we can play against. And so what we're going to do is we're going to create one called Wireless Hacking WPA. And so to do that, we're going to connect to our N300 router, that $10 router that we bought off of Amazon, or any other router that you want to set up for this. So what we'll do is we will go ahead and set that up. By default, my Netgear came up as Netgear 34. To join that network, I would use the password that it was given. On the back of your router, there is going to be a password listed. In my case, this password is going to be slowtable117. That is SLOWTABLE 117. Yours will be different, and it is printed on the back of your router. So at this point, it's going to go ahead and join to the network, as you can see here. Now with the Netgear, it's going to go ahead and open up a web browser, and we are going to go to http://www.routerlogin.net. Now on your router, it may be different. On the Netgear N300, that's what they end up using, and it's going to ask for your username and password. For us, our username is admin by default, and our password is password, P-A-S-S-W-O-R-D. Again, we set this router up from the beginning. We just wiped it clean out of the box, and that is what you're going to get. When you do that, it's going to bring you up to a graphical wizard. And this particular router actually will go through and walk you through a lot of these setups because they have this Netgear Genie software installed. So you'll notice here that the internet says error not connected. That's because on my router, because we're using this for a hacking lab, I haven't bothered to hook it up to the internet. If you plug this into a WAN connection, you would have that turn into the right color, which would be green and say connected. Now, what I want to do is change the wireless settings. So we're going to click on this wireless button. And the first thing I'm going to do is I'm going to change the wireless network name. So instead of Netgear 34, we're going to call this Wireless Hacking WPA2. Just so I'll know when I look for it later on, we'll know exactly which one we're hacking against. Because we don't want to be hacking our neighbor's Wi-Fi. That's illegal, and you're not supposed to do that. You'll get in trouble. So we want to make sure we're doing this properly. Now, what we're going to do is we are going to keep the WPA2 encryption settings, and we're going to change the passphrase. So in this case, we want to give it something difficult that's really hard to guess. So I'm going to use something that I like to use. It's called Dragon Breath. And I'm going to use uppercase, lowercase, special characters, all sorts of weird things so that it'll be a little bit harder to guess. And so in this case, I have dr at g0nbr3 at +h. That is a pretty long password. As you can see there, we have 12 characters in that password, uppercase, lowercase, special characters. Most security practitioners will tell you this is a fairly strong password and a good one to use for our wireless network. Now later on, we're going to be hacking against this. So if we do this as a brute force attack, it's going to take a long time. Hopefully this will be in our dictionary and we'll be able to find it fairly quickly though. You can pick whatever password you want. For our example, this is what I'm going to use. And then just hit apply. Now, because this does have the SSID broadcasting, we should be able to see that network show up in our wireless settings. On my particular Mac, I will click on the Wi-Fi logo up here in the corner, and we will see Wireless Hacking WPA2 is there, and it's ready for us to make connections to. So as we go in the future in these labs, you're going to start seeing, as we hack against these networks, you're going to see them again and again. In this lesson, we're going to talk about the various types of wireless network, starting with wireless A and going through the latest standard, wireless AC. So the first wireless standard that came out way back in 1999, and it was called wireless A, or 802.11a. It operated at a speed of about 54 megabits per second, which was pretty fast back in those days, and it operated on a 5 gigahertz spectrum. Now what that means is that's the radio frequency wavelength that this particular wireless network used. The good thing about 5 gigahertz is that you can get a lot of bandwidth inside that spectrum, with 54 megabits, or as early as 1999 being the first example of that. The bad thing about it, back in those days, those radios were fairly expensive, and so it really limited the growth of Wi-Fi. So instead, they became a consumer-grade product called wireless B, or 802.11b. And this one was introduced later in 1999, and it supported only a speed of 11 megabits per second. But the benefit of it was that it actually only used a 2.4 gigahertz bandwidth or radio frequency. Now, why this is important is 2.4 gigahertz is what was being used by cordless phones at the time. It's used in microwaves. It's used in a lot of consumer-grade electronics, and so it was very cheap to produce, and wireless started spreading like crazy. A couple years later, we moved up and we said, hey, we need faster speeds. 11 megabits per second is just not fast enough. So wireless G was introduced, and that was in 2003. Wireless G actually went back to that 54 megabits per second standard that we had all the way back in 1999 with wireless A, but it still did this inside the 2.4 gigahertz spectrum. Now, over the years, we have a demand for more and more wireless and faster wireless. So in 2009, wireless N was introduced as the next generation of Wi-Fi. This was 802.11n, and a lot of people have this in their homes now. Now, when this got introduced, it went and it wanted to support that 2.4 gigahertz spectrum that was currently being used by wireless B and G so that people didn't have to upgrade their old devices. And by doing that, they really limited themselves to only about 108 megabits per second. But at the same time, wireless N and a lot of the routers, it also supported 5 gigahertz again, going back and supporting wireless A as well. And when it did that, they could actually open up to 300 or 600 megabits per second and start getting really fast Wi-Fi again. Now, once we move into AC, which is the latest one, which started coming out in around 2012, 2013, you'll see 802.11 AC. It is out there in wide proliferation at this point, and it only supports 5 gigahertz as far as the radio frequency, but its speeds more than make up for that limitation because it can actually support up to a gigabit per second or more, giving us true wireless at a very fast speed, similar to what you get in a wired connection. And that's kind of the history of how wireless has evolved. So in this course, and the 802.11 standard that we are going to be going against is wireless B, G, and N. We're going to be focusing on that 2.4 gigahertz spectrum. Now, it's not that the techniques we're using won't work on the 5 gigahertz spectrum. It's just that the Alpha Networks card that I recommended you buy, it only works on 2.4 gigahertz networks. There are some new packet injection type wireless cards that will support 5 gigahertz, but they are much more expensive, which is why for this course we focused on those B, G, and N networks. And to be honest, every place you go is going to have backwards compatibility for that 2.4 gigahertz spectrum because so many people still have devices that have that built in. And so you're going to find it everywhere, and it'll be easy for you to exploit it as we move forward. So in the next lab, we're going to change our MAC address. And you may be wondering why you want to do that. Well, there's lots of different reasons. One of the most common is you're on travel and you want a new MAC address each time because you don't want people tracking you, because the way we track devices on a network is based on your MAC address. Each network card has its own individual MAC address. It's a 12-digit hexadecimal number. The first 6 digits of that is going to tell you the manufacturer of that card. The last 6 are more of the identification of that particular card in your system, much like a serial number. Now, if you want to change that MAC address on Kali Linux, it's really easy. Kali Linux and most versions of Linux come with a built-in program called MAC Changer, M-A-C-C-H-A-N-G-E-R. Now with MAC Changer, we can go and take that permanently assigned MAC address and change it as often as we want, and it takes just a couple of seconds. So if you want to learn more about MAC Changer, at your Kali prompt, type MacChanger --H. That will bring up the help file, which will show you all of the options. But I'm going to show you the big 3 right now that you're going to need to use. The first one you're going to use is MacChanger-P. And when you do MacChanger-P and then the wireless card you're using, such as WLAN 0MON, you're going to be able to bring back that permanent MAC address back to your card. So all those changes you do can be undone instantly and go back to default. Now, the second one that you're going to use, and the one that we're going to use when we try to spoof our MAC address, is we are going to use -M. And so we do MacChanger-M, and then the MAC address we want to manually assign it, and then WLAN 0MON. By using this command, we can tell our card to tell whatever system is asking what its MAC address is, to say that its MAC address is really X instead of Y. And that's what we're going to use in our lab in the next lab. Now the third one is one that we'll use when you want to get a randomly assigned MAC address. And it's really easy. You just use MacChanger-R WLAN 0MON. And when you do that, your MAC address has been changed to some randomly assigned digits. Now, why would you want to use that? Well, have you ever been to the airport or a hotel and they say you can have 15 minutes of free Wi-Fi, and after 15 minutes, it kicks you offline? Well, it does that based off your MAC address. So if you went in there and did this MAC changer-R, boom, you've got another 15 minutes ready. And you can do it again and get another 15 minutes, and another 15 minutes, and so on, right? Again, the reason we're going to use MAC changer in this case is because we needed to use it to bypass MAC filtering, as you'll see in the next lesson. One of the things you may come across as you're hacking wireless networks is a network that just will not seem to let you to connect. Even though you may have the password, it's still not letting your terminal connect to them. Now, why might that be? Well, it's probably because they're using something called MAC filtering. And what MAC filtering does is it actually creates a whitelist of devices that are known to the network and allowed to connect. And if your MAC address of your network card doesn't match one of those, you can't get on the network, even if you have the right username and password. So how do you overcome that? Do you have to steal one of their devices? Well, that's one way to do it, but the other way is to actually change your MAC address on your card to their MAC address. And it's really easy and quick to do. And I'm going to show you how in this particular example. So the first thing we want to do is ensure that our card is still in monitoring mode. And to do that, we're going to do iwconfig. And you'll notice here that my card is still in monitoring mode. If yours isn't, you're going to have to do the shutting down of the card, reconfiguration, and then bring it back up online. Now, once you've verified that it is actually up and running, you want to start scanning for networks and see what's out there, and see if there's any devices associated with an access point that we can spoof. So we're going to use arrow dump ng, and then the card that we're using, which is WLAN 0 MON. And off it goes, starting to scan. You can see we have a couple of access points up here, but we don't have any associated stations with a particular access point. So now we've got a couple here, and the one we're looking at is going to be our web network of wireless hacking, which is this C887. So once I see that down here, we'll see if anything is associated with it. And there one just popped up. You can see that our workstation, this is my iPhone in this case, is 90FD61AC. So I'm going to go ahead and cancel that. And we're going to use that as the MAC address that we want to mimic. So I'm going to go ahead and copy that. So how do we change our MAC address? Well, the first thing we're going to have to do is shut down our network card. First, let's see what our current MAC address is. So we'll do ifconfig. And you'll see here that our MAC address is 00C0 right up to here, those first 12 digits. So we're going to use ifconfig, and then we're going to use the network card itself, which is WLAN 0 MON, and then down. So now the card should be off. As you can see here, it's no longer showing up in the ifconfig. And now we're going to use a program called MAC changer. And all we have to do for this is do MAC changer -R, which gives us a random MAC address, WLAN 0 MON. And if we do this, this is going to assign us a new random MAC address. So let's see that. Our current one was 00C0CA844C28, and now we have this new random MAC address. Well, that helps if I just want to mask who I am, but it doesn't help in the case of me wanting to spoof myself as someone else. So instead, we're going to have to actually change the MAC address to the one that we copied off of the iPhone to mimic that user. So how will we do that? Well, just like any command, if you're not sure what to use, just use -H for help. So we'll do MAC changer -H, and you'll see that you can use the changing of another MAC address by setting it to one that you want. And in this case, it is going to be -M for MAC, and it will set the MAC address. So all we have to do is do MAC changer -M, paste in that MAC address for the iPhone that we copied, and then give it the WLAN 0 MON and hit enter. And now you'll see that it says my new MAC address is that iPhone MAC address that we were using. So now we would be able to connect to the access point, and it will think that we are that iPhone because we have now taken over its MAC address. So, what is promiscuous mode? Well, network cards by default only want to listen to their particular name, and their name is their MAC address. So if I go onto a network and I say, hey, listen to all of the traffic that's out there, and go ahead and put it into a file, well, by default, it's only going to do that when it hears its own name or its own MAC address. That's like when you walk into the bar and someone says, "Hey, Jason," and I go, "Ah, they're talking to me." But if they yell out Dave or Mike, I'm not going to listen because they're not talking to me. Well, when you go into promiscuous mode, you tell your card that I don't care who they're talking to, I want you to listen to everything. It's like a tape recorder or your iPhone. If you hit record on it, what are you going to hear? You're going to hear everything, not just things that are said to your iPhone, right? It's going to pick up everything in the room. Well, when you go to promiscuous mode, also known as monitor mode, that's what your network card's going to do. So in the next lab, I'm going to show you how to turn your card into promiscuous mode or monitor mode. It's pretty simple, and I'll show you two different methods of doing it. But it's really important that we do that because if we want to get onto the network and we want to listen to everything that's out there in the wireless spectrum, we want to listen to everything that's going on, not just the stuff directed at our card. Because when we come up in a new environment, how many people are actually talking to our computer? Well, none. Not until we actually connect to a network. And so we want to be able to listen out there and go, what networks are in this area? Who can I see? Who can I touch? Who can I hack? Well, that's where this promiscuous mode comes in, and I'll show you that right now. So the first thing we want to do is we want to set up this wireless network card. So we're going to go ahead and open up our terminal. I'm going to make this larger so everybody can see it. Okay, so the first thing we want to do is we want to make sure that we only have the wireless network card that we want on this Kali machine. So to do that, we're going to type in ifconfig, and this is going to show us every network adapter that's currently on this computer. You'll notice there's two. There's LO, which stands for loopback, and that one is going to be on every machine whether you have a network connection or not. It is the machine that calls itself. And then we have WLAN 0. And this WLAN 0 is the wireless network card, that USB card that we have just installed. So what we want to do is first we need to take that card down so we can reconfigure it. And to do that, we're going to do ifconfig, and then the name of the card, which is WLAN 0, and then down. And you'll see we get the prompt. So now if we do ifconfig, you'll see that it is no longer listed there. We have taken this card offline so we can make changes to it. And the way we're going to make changes to it is we're going to use a program called iwconfig. And the way we do this is we're going to type in iwconfig, the card that we want to configure, in this case WLAN 0, and what we're going to do is we're going to put it into promiscuous mode, also known as monitor mode. And that is going to allow us to look and listen to every piece of traffic on the network, whether it's listening to us or not. So normally when you have network traffic going around, the MAC address, there's a sender and a receiver MAC address. And so if you're not the receiver, and every card is going to see all traffic that comes to it, but when it doesn't hear its name or its MAC address, it just ignores that traffic and lets it pass on the network. What we're telling our network card here to do in monitor mode is listen to every piece of traffic, whether or not it was addressed to you or not. So if I'm sitting in a room and people are talking to Heather and Mary and John and David, I would just think if I put my hands over my ears and went, no, 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 I'm not listening because you didn't say Jason. Well, when I go to monitor mode, I'm going to listen to everything, whether you said Jason or not. And so I can log all that information and use that in an attack later on. And that's what we're going to be doing here. So now that we have done that, what we want to do is verify that it's in monitoring mode. And to do that, we're going to type iwconfig. And you can see here that the WLAN 0, wireless network 0, is in monitor mode. So it is working properly at this point. So the next thing we want to do is we need to turn the card back on. And so we'll do that by doing ifconfig, and then WLAN 0, and then up. And then to confirm that works, we're going to type ifconfig again. And you can see that our card is back up, but we are now in monitoring mode. And you can see that again by doing the iwconfig. And you'll see that we have an up card and it is in monitoring mode. So now we're ready to start working on the network. So now we have our card in monitor mode and we can do all of the listening we want. But what if we want to put this card back to the way it was? Well, what we're going to do there is we are going to, again, turn off the card, reconfigure it, and this time we'll put it in what's called managed mode, which is the normal mode that a network card operates in. So we're going to do ifconfig, WLAN 0, down. That again shuts down the card, and now we can do iwconfig, WLAN 0, mode managed. And it's going to go ahead and set that mode to manage. So if we do ifconfig, WLAN 0, up, it's going to turn that card back on. And then what we're going to do is do an ifconfig and an iwconfig to verify the settings we made. are back to normal. And you can see here the WLAN 0 is on, and if we do iwconfig, we do see that we are back to a managed mode where it is looking for an access point. So that is the first way to take your card into or out of promiscuous mode. Now I'm going to show you a quicker way in the next lecture. Alright, in the last lecture I showed you how to set up your card into promiscuous mode using the ifconfig and iwconfig commands. Now in this one I'm going to show you just a slight variation that is a little bit shorter and a little bit quicker to use. This is the one that I will probably use throughout the rest of the lectures because it's the one I'm most comfortable with, and it really is just a little bit quicker. Okay, so in this case what we're going to do is use ifconfig WLAN 0 down. And the reason we're doing that again is to put our card into a configuration state that we can make changes because it's offline. Now we're going to use a tool called airmon-ng. And when we use airmon-ng, we're then going to use the command start WLAN 0. And by doing that, it's going to go ahead and start up that network card for us in the monitoring mode. Now it is going to change the name of our interface from WLAN 0 to now be known as WLAN 0 mon as we go through, and you can verify that. And so to check that, we're going to use ifconfig, and you can see that WLAN 0 mon is up and running. So the next thing we want to do is we want to make sure that it starts scanning and seeing what things are on the network. So in this lesson, we're going to talk about aerodump-ng because we're going to be using that a lot as we go through. So the first thing we want to do is we want to bring up the help file. Whenever you don't know how to use a tool in Linux, there's two ways of doing it. The most common way is using what's called a man page. So if you type in MAN, it stands for manual, and then the name of the command that you want. In our case, aerodump-ng. Now, when we bring it up, you can see that this is a wireless packet capture tool for aerocrack-ng. In this case, it's aerodump. It's going to allow us to capture all that raw traffic that's going over the wireless network and put it into a capture file or a text file. We can log all of that, and then we can know exactly what we've got, and we can crack it or pull out the information. So you'll see here that if you use TAC-H, it shows you the help screen. If you do TAC-I, it's the IVs, and you can go through all of this information. Now the ones that we're going to use specifically in our lab is going to be on the next page here. It is -C or -- channel, which is going to indicate the channel that we want to listen to. By default, it does frequency hopping on all 2.4 gigahertz channels, and we're going to be looking at BG and N networks operating at 2.4 gigahertz. Now the second one we're going to use is BSSID, and you'll see that here. You can use -D or --BSSID. I tend to use the --BSSID even though it's more typing because it makes it a little clearer of what we're doing here. In this case, we are only going to show the networks that match that given MAC address so we can focus on what we want and get a smaller capture file that really focuses on what we need. The next thing we need is --write, and you'll see that back here on this first page. It's either -W and then you give it the file name, and this is going to be the dump that we're going to end up using. So what I ended up using is I usually use something like the name of the network dump. So if I'm using wireless hacking, it'll be wireless hacking dump, and then it's going to add on to it a .cap and a .csv as the two types of files that are going to be created when we do an aero dump. And then the final thing is we're going to give it the name of the interface that we want, which as you can see here, the format is aerodump-ng, the options you want, the --BSID, --channel, --write, and then the interface name, which is WLAN 0 MON. So to get out of this and get back to the prompt, we're going to use Q to quit, which is going to bring us back up here, and then I'm going to type in clear to give us a brand new prompt, and we'll be ready to pick up in the next lecture with actually using aerodump-ng. So the next thing we want to do is we want to make sure that it starts scanning and seeing what things are on the network. And we're going to use that by using aerodump-ng, and it's aerodump-ng and then the name of your card, in our case WLAN 0 mon, and it will start scanning the networks out there. I'm going to let this run for about 30 seconds and you'll start seeing different networks popping in and out. Alright, so this has been scanning for about a minute. What I'm going to do is I'm going to go ahead and cancel the scan by hitting Control and C. And I'm going to leave that on the screen so we can talk about a couple of those things on there. So the first thing is this BSSID column, this first column. Now what are those things in that column? Well, they're MAC addresses. These are the MAC addresses of the various network cards that are doing talking to various base stations, wireless access points, or other devices if they're doing point-to-point. And so you can see here that we actually have the networks we were going to go after, which is wireless hacking WPA2. You can see wireless hacking, which is our WEP encryption one. And then you'll see some of my home networks, the Dion and the Dion guest. Now you also see some of my neighbors' networks. We have a guest one here for FBI Van 331, which is my next door neighbor, and FBI Van 331, which is encrypted with WPA2 because he doesn't want anybody using that one. And then you'll see this 330 is another neighbor, Elisa's Malibu, which is somebody's car, has a Wi-Fi spot in it. And you can see as it goes through the different things, including somebody's printer here that's sitting on the network. So now, what do we see next? If we look over here at this column, it is CH, and CH stands for channel. This is the channel that it's being operated over. Now, for most things, if you're using a 2.4 gigahertz spectrum, which is what we are, talking about wireless B, G, or N at this point, you're going to be using either channel 1, 6, or 11. And so right now we are set up to monitor those channels, and we're seeing that most people here are using either channel 1, channel 6, or channel 11. There are a couple that have chosen to use 8 and some that have chosen to use 5. Now that is usually because the device has auto-configured itself and it thought there was less interference there. We'll talk about those spectrums again in our theory lectures, but generally you're going to see people on 1, 6, and 11 to minimize the overlap with other channels in the area. Now the next column we want to look at is this ENC column, and I kind of skipped ahead here a few minutes ago, and you can see that stands for encryption. We have a WPA, WPA2, we have OPN, which stands for open, no encryption, WEP, which is wired equivalent privacy, which is what we're going to be hacking shortly here, and then again all of these other ones are WPA2, which is the most secure encryption out there, and it is the latest standard, but we will show you how to hack that later as well. Now, the final column here that I want you to see is this ED, which is the SID that it is connected to. And the SID here is the service set ID, is the name of the network, and we already talked about that as well. So, when we go ahead and we use arrow dump, the way that we are going to use it is we want to find the network that we want. So we use that arrow dump ng WLAN 0 mon, and that got us something that looked like this. Now, it constantly is changing and moving around, unless you cancel out of it using Control-C like I did. Now, once you find something you want to listen to, you then want to dump that information that's being transmitted onto a file so that we can attack it later, because that's how we're going to be able to break out the keys. So, what I want to do is figure out which network I want to go after. Now, because we're in the WEP lessons, we're going to be going after wireless hacking, which is a WEP terminal encrypted. And what we need for that is we need this encryption, we need this server set ID. And so what we're going to do is we are going to type in the command arrow dump ng, and then we're going to use -- channel space and the channel number for it. In my case, that's channel 1. And then we are going to use BSSID, excuse me, and then the MAC address for the one that we need. And in our case, it was this one. And so I'm just going to copy that so I don't have to type it, and hit paste. And from there, we can then tell it where we want to write, which is -- write, and then wherever you're going to call this file name. So we'll call this wireless hacking dump. And then we're going to use what card we're using, which was WLAN 0 mon. And so we'll go ahead and do that. It's going to be arrow dump ng -- channel 1 -- BSID, the MAC address, -- write, wireless hacking dump, and then WLAN 0 mon, hit enter, and away it's going to go. Now you'll notice it's only listening to one channel, and it's only listening for one SSID. So essentially we've told it, hey, we know you can listen to everything in promiscuous mode, but right now I want you to focus on this channel only. And you'll notice here the number of beacons is going up and the number of data is going up because it's capturing everything on this network. And what we're going to do is we're going to capture all of this so that we can then crack it later on as we go through our WEP encryption and WEP hacking lab. WEP, or Wired Equivalent Privacy. So what is WEP? Well, WEP came out as part of the 802.11 wireless standard. It came out as one of the first ones because they realized that if you're going to do wireless networks, you had to have some security or people could just sniff your traffic and grab it out of the air. And when WEP first came out, it was decent enough and it did the job. They call it wired equivalent privacy, but honestly, it doesn't give you the same protection as a wired connection. So what is the flaw with WEP? Well, there's a couple of flaws. The first one is that when WEP was developed, it was developed without the academic rigor and public check of the algorithm to ensure that it actually worked properly without having significant vulnerabilities. And the big vulnerability here is what we call initialization vectors. So these IVs, or initialization vectors, happen inside of a 24-bit key space, which means they are stored with a series of 24 ones or zeros. Now that may sound like a lot, but it really is only about 16.7 million options that are there, which back in the late 90s when this was developed was decent enough that it would keep people out. But with the last 5 to 10 years worth of computer upgrades, that 16.7 million choices can be cracked in just a matter of minutes, as you're going to learn in our lab. Now, the other thing that WEP uses is what's called the Revest cipher, and that's the RC4, Revest cipher version 4 that it's using. And that uses that for the confidentiality, and it also uses a thing called a cyclic redundancy check, which is a 32-bit redundancy check for its checksum to make sure there's integrity of the data as it passes over the network. Now again, the problem here is that Revest cipher 4 is kind of an old system, and the key space that it uses for its encryption key is pretty small. So when we start talking about WEP, there's actually 3 varieties that exist. The original one was only 64 bits, which had 64 bits of ones or zeros, which should give you enough protection, except computers got faster and they could crack it now. So that only gave you a 40-bit key size when you started dealing with 64-bit WEP. Now, when you dealt with 128-bit WEP encryption, you actually only got a key size of 104 bits. And when you got to 256 bits of WEP encryption, which is the latest standard, you actually get 232-bit key size. But the flaw still remains those initialization vectors. Even if you're using the 256-bit WEP, it still relies on initialization vectors, which only go back to 24 bits, making this a very easy problem to solve for a computer when you start doing cryptanalysis. Now, the programs we're going to use are going to be able to slice through WEP very quickly. On my machine, I've been able to crack any WEP I want within about 5 to 10 minutes without much effort. And the busier the network is, the more those IVs or initialization vectors are transmitted, the quicker I can collect them, get all of them, and guess the password. And it works flawlessly every single time. So I'm going to show you that as we go into the labs right now. Now in this lesson, we're going to talk about the various steps needed to crack WEP. When we get to the next lesson, we're going to actually pull out the lab environment, go into Kali Linux, and crack a WEP network. So the first thing we have to do is we need to verify that our network card is in monitoring mode. We're going to do that by checking with iwconfig. If you type iwconfig at the prompt, you'll find out if your card is in monitored or managed mode. If it's in monitor mode, that means that it is promiscuous and it can listen to everything on the network, which is what we need to be able to do WEP. The next thing we're going to do is we are going to take that monitor mode card and we're going to start listening to see what networks are out there. And we do that by using arrowdump ng. So we'll do arrowdump ng, WLAN 0, mon, and when we do that, we'll see all of the networks populate and we'll find the network we want to hack. In our labs, that's going to be wireless hacking, which is a WEP network. We'll find its BSSID, which is its MAC address for the access point, and we're going to highlight that and copy that so that we have it in our memory so we don't have to type it each time. The next thing we're going to do is cancel out of that, and we are going to use a specific command with arrowdump, giving it the channel, the MAC address for that wireless access point, a file name that we want to dump all the packets that are going to that network on, and the card that we're going to be using, WLAN 0 mon. Put all that in a command, hit enter, and it will go through and start capturing everything addressed to and from that access point and dumping it to a text file or a capture file. Once we have enough initialization vectors, which generally is going to be somewhere around 10,000 to 20,000 initialization vectors, we'll be able to take those and we'll be able to crack it using a tool called aircrackng. And to use that, we just type aircrackng and the file name. It will churn away on that file, usually taking no more than 60 seconds, and be able to come back with the key for that WEP network, which is that hexadecimal key that we used setting up our lab earlier. So that's pretty much it. That's the steps that we need to be able to do WEP cracking. Sounds pretty easy. Let's move into the next lab and we can see how it works. In this lesson, we're actually going to crack the WEP network. Now, I went back to the command prompt here, and we've already gone through your information gathering in a previous video, so we're going to go through that stage fairly quickly here, but I want to show you just from start to finish how quickly you can crack a WEP network and how insecure it truly is. So the first thing we're going to do is we're going to start with arrowdump ng, and then the card that we have, which is WLAN0MON. And notice it's starting to scan for that particular network that we're looking for. In our case, we already found it. It is wireless hacking, this WEP network right here. And this is the BSS ID, or the MAC address for that network. So for us to attack it, we are going to use arrow dump ng again. And in this case, we are going to specifically tell it which channel we want to go after, which is channel 1, right here from the wireless hacking network. We want to go after the BSS ID that was provided for that network. And we want to go ahead and write that data to a file, which is going to be wireless hacking dump, is what we're going to call that file. And then we're going to give it the card itself, which is WLAN0MON, and hit enter, and off it goes, starting to scan the network, which is helpful, but we're not quite there yet. Notice the data packets are climbing, but we haven't yet associated ourselves to that network to be able to start doing things like packet injection and capturing those initialization vectors. So I'm going to go ahead and put this up here to make some extra room, and we'll just bring that right across the top and let it continue to run. We're going to open up a new terminal, and I'm going to bring that down here to the bottom. Now, in the new terminal, what I need to do is I need to start doing a authentication to the network using fake authentication, which is our first step in the hack. So that first step in the hack is that we are going to do a program called air replay. And in air replay ng, we are going to use fake auth as our command, 0 for infinite attempts, -a, and the MAC address that we're going after, which again we still have pasted right there. And then we're going to use the MAC address that we're coming from, which we have to find ourselves. So we are going to open up another terminal. You can see how you start getting quite a few terminals, and just type in something like ifconfig. When you do that, you're going to get the MAC address for WLAN0MON, and the first 12 digits here is that MAC address for our network card. So I'm just going to copy that, and then we can paste that in. Now this uses dashes, but for this particular command you have to use colons. So I'm going to arrow through and change those to colons, as you can see. And the command's not done yet, because what's the one thing we haven't told it? We haven't told it which card to use. So we have to use WLAN0MON. And then we will hit enter, and off it goes, sending a authentication. We now have an authentication made with this network. So we can move into the second phase of our attack, which is going to be the packet injection. So for the packet injection, we are going to still use the air replay command, and most of it is going to be the same. So what I'm going to do instead of typing it all is hit the up arrow, which will bring back the last command I used. The big differences here is we are not going to use fake authentication anymore. Instead, we want to use an ARP replay so that we can create additional traffic on this network. Instead of A for the access point, we're going to use B for the access point, which tells it that's the base station. We're still going to use the card that we're coming from and the network card WLAN0MON. When we hit enter, off it goes, and notice that we have a couple of ARP packets here, and our data is going to start going up. We have a lot of frame loss. Once you have a couple of ARP requests that have been successful, you can hit Control-C and stop that. Now, with this attack, it does help if this is a busy network. Right now, as we're doing this, you can see the data packets are going up. The reason those data packets are going up is because I'm streaming YouTube on the device. This base station here, this client, which is my iPhone, is talking to this access point and streaming YouTube, which is collecting a lot of data. Now, the next thing you want to do is start cracking. And every 5,000 data packets that go up, it will start trying to do another attempt. And it's really easy. You just use aircrack-ng and then the file name of what you're going to be using. So let me clear the screen here. And the file that I'm going to be using is wirelesshackingdump2.cap. And the reason it's the second one is because I've run this attempt once before showing you. So all we're going to use is aircrack-ng and then the file name that you're going after, and hit enter. And off it goes, starting to crack away. Right now it already has 14,000 initialization vectors collected, and you can see that here from the data, but that wasn't enough. So when this hits 15,000, you're going to see this kick off again without me doing anything. and we'll see if we can crack that key. So here it goes again. It's going off and testing the different keys, and it didn't find it. So it'll try again at 20,000. Generally, it's going to find it somewhere between 10,000 and 25,000. It really depends on where that particular key is inside the key space, depending on what that hexadecimal password was that we used. So again, you can see the data packets climbing up as I'm streaming different YouTube videos. Every time I start another video, it starts downloading all that data. All those frames have an initialization vector in there, and they're able to be captured so that we can start seeing that information. So now we have over 20,000. It's going to try again, and there it is. It found our key 172583AEFA. So we now have a key. What are we going to do with it? Well, the next thing we want to do is we want to see if that key actually works and be able to get onto a network. We can do that through Kali, or we can do it through your Windows machine or your Mac machine. It depends on what your ultimate goal is. For this example, I'm going to show you how to use it inside your Macintosh machine. You can do the same thing in Windows and again in Kali. So if we can cancel this capturing at this point, so we'll hit Control-C, and we're going to switch back to our client machine, in my case Macintosh. So now that we're back on our Windows or our Macintosh machine, you'll connect to that wireless network just like you normally do. So we're going to go down to wireless hacking, and it's going to ask us for the passcode. My passcode that we just cracked was 172583AEFA. And if I go ahead and join, we should see if I can pull an IP address from this network. And if we look at it, you can see here we did pull an IP address from this network, and we are connected to that access point starting with C8A7, that BSS ID, which is the one for wireless hacking. So our hack did work, and it was successful. So in the last video where we cracked the WEP key, we then went into our Windows or our Mac machine to be able to use it and connect to the network. But what if you want to connect your Kali Linux machine to that network to do further exploitation? Well, we can do that too. And the way we're going to do that is we are going to close this window and maximize the top window. I'm going to type in clear to give us a new prompt. And we are going to have to shut down our network card or stop it from monitoring. And we're going to do that using airmon ng. Stop WLAN 0 mon. So if you remember before, we used airmon ng start WLAN 0 mon to turn it into a monitoring card. Well, now we have turned it off of monitoring. And we can verify that once we get back to the command prompt by using iwconfig and seeing that it's looking for an access point. So we'll do iwconfig, and there it is. We are back to our managed mode looking for an access point. Now, how do you configure it for an access point? Well, the easiest way in Kali Linux is to use the graphical user interface. So you just click up in the top corner and go to Wi-Fi not connected. Select your network and then choose the one that you want to connect to. In our case, it's the WEP network wireless hacking. It'll then prompt you for your password. And that password again was 172583AEFA, and then hit connect. And if it's successful, we are going to be able to pull an IP address using that. We can double check that using the ifconfig command. And you see up here that we do have a couple of bars of signal. And we did pull an internet address, an IP address there at 192.168.1.160. So now that we're on the network, we can do all sorts of other exploitation, other hacks that don't relate to wireless, because this just gets us onto the network. Now we can do whatever else it is that we need to do. So in this lesson, we're going to talk about WPA and WPA2. What are they? Well, it's version 1 and version 2 of the Wireless Protected Access Protocol. Now when we talk about version 1, or WPA, WPA uses a thing called TKIP, which is a Temporal Key Integrity Protocol. Now with TKIP, the way it works is it actually created a unique key for each and every packet. And this per packet key made it so that it was a dynamically generated 128-bit key each and every time. This added to the security of WPA and solved some of those problems that we had with the earlier WEP. If you remember from WEP, we talked about the fact that they had these very small initialization vectors that were only 24 bits. Well, here we're using TKIP at 128 bits, making it much harder to crack. So this was a big improvement over WEP. Now, WPA only came along a couple years after WEP, and it didn't quite solve all the problems that we had with WEP. So the problem that exists with WPA is that although it was stronger using TKIP, and this is used for integrity checking in WPA, instead of the CRC that was used in WEP and instead of those initialization vectors, it still isn't really strong by today's standards and can be fooled by using reinjection and spoofing of packets. So when they came out with WPA2, they decided to change TKIP and they made it something called CCMP. And CCMP stands for Counter Mode Blockchain Message Authentication Code Protocol. Now, WPA2 was introduced in 2006, and pretty much any router or card that was made from 2006 onward is going to support WPA2. This is the latest and greatest standard. Now, the good thing about WPA2 is it really is an unbreakable standard because it's relying on encryption that has the Advanced Encryption System, or AES. Now, with WPA2, it can use 128-bit keys or 256-bit keys. Either of those are very, very hard to crack and very, very strong. So WPA2 uses CCMP and AES to give it confidentiality and integrity of the wireless data that's being transmitted. And this is going to give us a good level of security if a strong password is used. And that's where we're going to break this thing. Because we're not going to be attacking the AES algorithm itself. It's too hard to crack. Unlike WEP, where we're able to collect those initialization vectors and crack that in just a few minutes. So for WPA2, really the only way to break it is to go after the password or the passcode. We can go after those passwords using a brute force or a dictionary attack, or we can go after the passcode that's used in WPS, which is one of those automated configuration systems that made operations nice, but security more lax. Now, if you have a good password on your WPA2, something long and complex, it's going to take forever to guess it by brute force, and it's going to take forever to find it in a word list. So it's going to be really challenging. Now, the techniques we're going to show you are going to work each and every time. The only caveat is that these techniques may take you 1 billion years or more if the password is really long and complex, making it that some networks you're just not going to be able to get to in your lifetime, and you'll have to move past those. So we're going to cover brute force and dictionary attacks in the next lessons, and then we'll move into hacking a WPA2 network. Brute force attack. So what is a brute force attack? Well, a brute force attack is great because it's going to work each and every time to find a password or a passcode. The only problem that you really have with a brute force attack is they can take infinitely long. So if we have a very short password like a 3-character password, well, there's not very many guesses we can make. We can go A, AA, AAA, AAB, AAC, and we can keep going through, and eventually we're going to find out that the word we used was bad, BAD, right? Or something like that. But if we start using something that has a 24 or 25 character password, well, it's going to take us a long time to get there. It may even take us millions or billions of years. So brute force really works by calculating every possible combination that's out there, anything that can make up a password. And now when you use just letters or numbers, that's not so bad. If I use just numbers, for instance, there's only 10 choices. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I use a password based on 10 digits, such as a phone number in the United States, well, how many combinations could I have? Well, there's only 9,999,999,999 of them, right? Or just under 10 billion combinations, because there's 10 places and each digit can be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And so if I was going to brute force it, I could start with all zeros, then all zeros and a 1, then all zeros and a 2, and I can keep counting up until I got to that number. But if my number started with the 410 area code, for instance, I'm going to have to go through 400 million things before I ever get to that particular number. So that can make it very time-consuming and very difficult. Now, as that password length increases and the number of options increases, the problem becomes infinitely harder. So if you've known about most passwords nowadays, they're going to ask you for uppercase and lowercase, because that's 26 lowercase letters and 26 uppercase letters. Then they'll ask for numbers, that's 10 more digits. And then they'll ask for special characters, and usually there's 5 or 10 of those. And so when you add all of those together, you start getting into 60 and 70 options per character, and your password has to be 10 characters or more long. You can see how this gets to be really difficult, and it can be really time-consuming. Now, alternatively, the attacker can try to guess the key that was created from this password by using a deviation function. And so instead of guessing in order by going 1, 2, 3, 4, 5 and counting up, they can actually say, well, I know that person likes dogs, so I think their password is going to start with the word dog, and then it's going to be a series of numbers. So they can make dog 1, dog 2, dog 133, 134, and keep guessing that way. That will help shorten down your brute force attack if you have some good information, but again, that's only as good as the information you're able to get. Now, when we start talking about AES and WPA2 encryption, we're talking about a 128-bit key. That means there's 128 possibilities in that length, and they can be a 0 or a 1 when you talk about it in binary. So it's relatively secure against brute force attacks. In fact, if you wanted to calculate how many combinations there are, there's 3.4 times 10 to the 38th power of combinations. That is a lot. That's like a billion combinations. It's just a ton of them out there. And that takes a lot of time to crack with a computer. So depending on where it is, it can take over 1 billion years for your computer to be able to crack 128-bit encryption. Now, we're going to do it in this class. How are we going to do that? Well, we're going to use a dictionary attack, and we're going to guess based on commonly used passwords and known words. And we'll talk about that when we get into the dictionary attack in the next lesson. So in the last lesson, we talked about a brute force attack, and we talked about the fact that it can just take way too long for us to ever be able to find that password. Well, what we're going to do in this class is use a dictionary attack. Now, what is a dictionary attack? Well, it's kind of like what it sounds. We're actually going to go through a list of passwords and try each one until we figure out which one is the right one. Now, how's this different than the brute force attack? Well, a brute force attack is kind of dumb. It's going to start with 1 and then go to 2 and then go to 3. But with a dictionary attack, we can actually start with A and go to Z, or we can have a random order list based on what things are most commonly used. For instance, there's a document that comes out every year that says these are the 100 most commonly used passwords. And one of the first couple is the word password. Some other ones are love and God. And so if we have those at the top of our dictionary attack, we may be able to crack this person's password very quickly. Now, when we start looking at these passwords, we're going to actually go through and take them, and it has to, with the algorithm, it's going to actually hash them, and then compare that hash to the hash that we've collected in traffic. That can take some time. So there's another thing that we can do, which is called a rainbow table. And a rainbow table is just a variation of a dictionary attack, where it already has all of those words truncated down to this hash value. And so we can compare hashes to hashes directly. Now in this class, we're going to use a standard dictionary attack because that's the programs that we're using are going to use those, and it's going to work fine for our purposes. But again, it's just something to keep in mind that if you're using larger things, you may want to use something like crackstation.net or one of the online rainbow tables, especially if you're trying to hack things like Windows passwords, as we talked about in our other courses. So when we talk about a dictionary attack here, does it have to be dictionary words? Well, no. The most common password lists are going to contain normal words. So puppy and cupcake and doggy and football and baseball and all those normal words will appear. But you can actually get some hacker dictionaries which basically have a lot of different letters changed out. For instance, if I wanted to have 2 words put together, like dragon breath, that may not be in a normal dictionary, but it may be in a hacker's dictionary. So if instead I wanted to take something like dragon breath and make it a little bit harder, security professionals will tell you to change out letters for numbers and things like that. So dragon breath becomes dr@th, bre at plus h, right? Something like that, as you can see here on the screen. And so it looks like dragon breath to me, and it makes it easier for me to remember, but I've changed out all of those letters and numbers. Now, the problem with that, a lot of the hackers' dictionaries have figured that out too. And they put this leet speak back into those dictionaries. And so things like doggy would be D0GGY, and password would be P@ $W0RD, things like that, so that they can find those two inside their dictionaries. So what does this mean to you? Well, it means if you're going to be hacking wireless networks, you need to have a good dictionary file. And so I'm going to show you in the next lesson how we can get a dictionary file into our Kali Linux, and we can use that in our attacks. Now in this lesson, we're going to talk about the word list that's used in dictionary attacks. Now, there's 2 different ways to get a word list. One is you can download one, and the other is you can create your own. I'm going to show you where you can download some first. So you'll go to your internet browser, in my case Google Chrome, and go to Google. Once you're at Google, you can simply type in something like password dictionaries. And you're going to find a lot of different places. One of the ones I really like is Crackstation, which is this first link here. And so you can click on Crackstation, and if you scroll down, you're going to see there's 2 that you can download. The first one is a 15 gigabyte file. It is huge, and if you're going to do a lot of password cracking, this is actually a really nice one to have. You can go through and download it either through torrent or through HTTP, which means you just click on it and download it. Now for our lab, we're not going to go ahead and do that because it's a really big file, and for a lot of you, that's going to take a long time to download on your connection. The second one you can do is the second one here, which is a smaller one. It's called the smaller word list, and it's human password readable ones only. These are real human passwords that people have found through various data breaches over the years, and they've combined them in one list. In this list, there are 64 million passwords, and that's the small list. This one is less than a gigabyte, it's 684 megabytes. Again, that's a lot of data to have to download if you have a very slow connection. So you can download and put into your Kali machine. You only have to do this once. Now, there's also two lists that come by default in Kali, and I'll show you that in a moment. So, from Kali Linux, if you want to look at the default word list you have, you can open up your terminal, and from your terminal, you can type cd/usr, which stands for user, /share/word lists. And from that directory, if you hit ls, you can see which directories we have there. We do have several different ones. You can see there's rocku.txt.gz, which is a compressed rocku, very large word list. There's also these other ones, DNS map, fast track, fern Wi-Fi, metasploit, and map list, and a couple of other ones. Now the one we're going to be using is rocku.txt.gzip, and we're going to go ahead and unzip that first. And what we're going to do is use gunzip and then rocku.txt.gz, and that will unzip that into a txt file. And you can see that right there is rocku.txt, which means that text file is ready for us to use. So let's go ahead and look at it. I'm going to use Pico, which is an editor that I like, and we will just do rocku.txt, and it's going to read this, which may take a couple of seconds because this is a very large file. And you can see here some examples of the passwords, 123456, 12345, and we can scroll down. And as you can see, it's just tons and tons and tons of passwords. So what I'm going to do is hit a control and then an underscore character, which will be go to line. And let's pick a line that's just a really, really large number. How about 15,000 will be the line we're going to go to. And let's see what password 15,000 is. Well, password 15,000 was Del Rosio. And what we're going to do is we're going to hit enter and add a new password here. We're going to add Dragon Breath, the one we set our router up with earlier. And here is Dragon Breath. So capital D R at G0, little n, capital B R 3 at plus T. And then to save it, we're going to hit Control O, which stands for write out. And that is going to save the file, so you'll hit enter. And the file has been written, and you can see here that there are 14 million lines to this file, which means there are 14,344,393 passwords in this particular file. That's a lot of passwords, right? So now that we're done, we'll hit Control X and exit out of that. And that's two of the ways that we can create passwords. The second way that we can create a password list is to use something called Crunch. And Crunch is a great program because it's going to allow us to create anything based on patterns. So, for instance, if I wanted to say that I wanted to pick a 4-digit PIN, and I knew that PIN had to be a number because it's a iPhone PIN, for instance, we're trying to crack, well, we would use the program Crunch. We would say the minimum and the maximum number of digits that we're going to use. In our case, it's both going to be 4. Now, if we knew it was a phone number, for instance, and it was going to be between 7 and 10 characters, we could put 7 and 10 there. And then you're going to give it the things that it can choose from. So it can be letters, numbers, special symbols, whatever. In the case of a 4-digit PIN number, it's got to be numbers. So it can be anything between 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each of those 4 positions can be one of those numbers. And then we're going to use a pattern if we know one. So let's say I already know that I watched the person as they went to their phone and I saw them put the number 9 as the first digit. Well, if I can guess that, that means everything else is only 3 digits, which means it's only going to have 1,000 guesses. So that's a lot easier for me to do. So we'll do a -T for the pattern, and our pattern, for instance, would be 9 and then at, because we don't know those last 3. And then I want to output that to a file, and we're going to go ahead and put that on the desktop. So it's root/desktop/ pin.txt, and we'll hit enter, and away it's going to go crunching out those numbers. Now, there is 10,000 possible lines, only 1,000 had to be created because we already knew the 9 in the front. And notice how quickly that went because we only had to create 10,000 things. If we decide to make something much longer, like 10 digits of a phone number, it can take us a while to go through and crunch all those numbers. So let's go ahead and look at that file. I'm going to minimize this. And here on the desktop is pin.txt, which we just created. And as we open it, you can see it starts out 0000001, 002, 003, all the way down to 9999999. So we have all of the options that we could possibly want here with the pin. So now that we've either downloaded a word list or created a word list, we're going to go ahead and perform a dictionary attack on a WPA2 network. Now if you remember before, we set our WPA2 network to have the password of Dragon Breath. And in our creating of a dictionary lab, I showed you where this rocku.txt file was, and we added Dragon Breath as the 15,000 entry. So we're going to see how long it takes to crack this password, knowing that it's in our dictionary, and seeing how long it takes to churn through 15,000 attempts. So the first thing we need to do is go back into our terminal. We'll expand that, and we got to check and see if our card is in monitoring or access point mode. And so we're going to go ahead and do iwconfig, and you can see here it is in managed mode, which means it's looking for an access point. So what we're going to want to do is turn that into a monitor mode, and we do that through airmon ng start wlan 0. And here we go, it's going to go ahead and kick that card into wireless mode, into monitor mode, and it should become WLAN 0 mon here in a second. And we'll verify that by doing an iwconfig once more. And you can see right here, we are now in monitoring mode, which is perfect. The next thing we need to do is we need to find that network we want to attack. And if you remember, the way that we did that before is we used arrow dump ng. And so we just do arrow dump ng, and then we put in WLAN 0 mon, and up to the screen we should start seeing the access point. And the access point we want is this wireless hacking WPA2 right here. And so what I need to do is copy that, we'll go ahead and cancel that so it'll stop scrolling on us, but we need to copy that access point right here, and we need to know what channel it's on, which is channel 1. Now, do we see anybody connecting to 28C6, that station? Well, yes we do, right here. We see there is something connecting to it, and that actually is my iPhone. We're going to need that because what we're going to do is send a deauthorization command to that iPhone, which will kick it offline for a second, and then when it reconnects, we're going to capture that handshake to a file, and then we're going to compare offline that file handshake to our passwords to crack the password. So now what we want to do is we want to capture all the data going to that network into a file, and then we're going to send a deauthorization attack. So the first thing we're going to do here is I'm going to scroll this screen down just a hair and make it so that we have a little bit more room. And we're going to actually create a second terminal window because we're going to need it in a second. Okay, so now we're going to go ahead and capture ourselves to a file. So we're going to do arrow dump ng WLAN 0 mon. We're going to do -c for the channel, channel 1. --BSSID, paste in the MAC address, and then --write and the file name, which is going to be wireless hacking WPA, and then hit enter. It's going to go ahead and start capturing that to a file, and you can see it's capturing that iPhone traffic. It's got just a couple of frames, and it's not really moving anywhere. So we can either sit here and wait for somebody to connect to the network and capture it, or we can force a connection, and that's what we're going to do here by using a deauthorization. So we're going to send a deauthorization, and the way we're going to do that is use air replay -ng. We're going to use --deauth, and then 0, which is how many deauthorization packets we want to do. In this case, we're just going to send an unlimited amount until I tell it to cancel. -a and the access point. So we're going to copy the access point we're targeting. And then we're going to use -c for the client that we're going to disconnect from that network so we can capture the handshake when that iPhone reconnects. And then we're going to do WLAN 0 mon, which is the interface card. And we'll hit enter, and off it goes, sending deauthorizations. And so we have captured it. We'll hit cancel. We sent about 6 or 7 there. That's enough for the handshake. So at this point, we can go back to the original monitoring and go ahead and cancel it. So now we can make our screen full screen again. We'll go ahead and clear the screen, and let's do an ls. And here you can see we have that capture file that we just captured. Now in there should be our handshake. So if you remember, we had that word list back in the user share word list directory called rocku, and that's the one we're going to use. So we're going to use a program called aircrack-ng, because everything is part of the Air NG suite. And the file we're going to use is this wireless hacking WPA-01.cap file, which is the capture file. Now, if you put -w, you're going to specify the word list. If not, it's going to attempt doing something like a brute force attack, and it's just going to take you forever. So when we do this -w, we're going to put in the word list, and the word list we're going to use is in /user/share/wordlist/rocku.txt. So when you have your full command there, aircrack-ng, the name of the file you want to attack where the handshake is captured, -w, and the list and where that word list is located. Go ahead and hit enter. You can see it's 9:28 p.m. here. Let's see how long this takes. Off it goes, cracking away. We're cracking about 830 keys per second, and it says it's going to take us 3 hours. Well, right now it already found it. It found it in just a couple of seconds there you saw. It only had to go through 5,000 keys until it found the particular key we wanted, which was Dragon Breath, and there it is right there. It went through about half of 1% of that entire word list. Because if you remember, that word list had over 14 million keys, and we put it in at about the 15,000 key mark is the line that we put it in. So you see how quickly that can work if your key is in the right place in the file. Now, if that key was number 14 million, it would have taken us probably 3 or 4 hours to find it. Now, if the key wasn't in any of those 14 million, like it wasn't when we originally found that file, we never would have cracked this key. And so it's really important to make sure that you have a good word list and to realize that you're not going to crack every network out there. Now, why is that important? Because from a security standpoint, if you're running the network, you have to have a long, complicated password. Because if you don't, someone is going to crack your network very quickly and very easily using the tools that we just showed you in this example. So what is WPS? Well, WPS was something that was done to save users time and effort of configuring their devices. It stands for Wi-Fi Protected Setup. Now, there's some flaws inside WPS, and we can exploit that to be able to get onto a WPA or WPA2 network without having to even crack the password. So the way WPS works is there's usually a button on your router or a PIN number on your router associated with it. And what you would do is you'd push that button, and then you would tell your device to configure, and it would automatically find the router and configure itself for that network. And when it does that, it uses a PIN code, and it's an 8-digit PIN code that it uses to be able to connect to this network. So once you push the button, it actually does a self-configuration between the device and the endpoint, and you can actually set up your wireless networks this way very quickly and easily, which is great for operations, but it's very bad for security. Now, the reason it's bad for security is because if somebody can touch your router because they're in your business, they can get on very quickly, but that requires some social engineering. Now, we can do some attacks against that WPS settings as well to guess the PIN number. The great thing about this WPS from a security vulnerability standpoint, if you want to call that great, is that there's only 7 digits to the PIN. So it's a fairly easy computation to guess all those digits and be able to guess the PIN number because you only have 10 to the 7th options here. So you really only have less than 10 million passwords, which sounds like a lot, but for a computer that's pretty quick. Now, the other flaw that's inside of WPS is that when you would guess a password, for instance, if I guess the number 5682283, it would go back and say, you got that wrong because those first 4 digits were wrong. But I can keep guessing those first 4 digits, and it will eventually tell me, you got the right first 4 digits. And now I only have to guess the last 3 digits, because the way it actually passed the password, or the passcode here, was it broke that 7-digit number into 2, a 4 section and a 3 section, which makes this an even easier problem to solve, because if I only have to go for 4 digits to get it right the first time, well, that's only 10,000 options. And then those last 3 are only 1,000 options. So it makes the problem very quick to solve if you start going against a WPS-enabled network. For this reason, a lot of newer networks, people will turn off their WPS. But in a lot of consumer grade and small business environments, WPS is still enabled. Why? Because it made configuring networks easy, and people like easy. So they set this up, they leave it up, and it makes it really simple for us as attackers to be able to get on these networks, as you'll see in the demonstration in the next lab. Now in this lesson, we are going to conduct our WPS or Wi-Fi Protected Setup attack. What we're going to do here is work against that 8-digit PIN. Now the last digit of that is actually a checksum, so we only have to calculate the first 7 digits. And if you remember, I talked about that this breaks it up into 4 digits and then 3 digits. So it's only 10,000 and 1,000 combinations we're looking at, so it shouldn't take too long. Now the biggest detriment here is as we go through and hack it is the program we use here, which is called Reaver. It actually will have to wait about 5 seconds in between each attempt. Now by doing that, that is going to slow us down, and if it's a very high number pin, it could take all night for us to crack. So we'll just let it run. I'll pause the video and we'll come back depending on what the passcode is on this particular router. The first thing we need to do is see if our card is in monitoring mode. So we'll do that by doing iwconfig again. And we can see here that it's actually in access point mode. So do you remember how we changed this back to monitoring? That's right, we're going to use air mon ng start and then WLAN 0, which is the name of this wireless card. We'll hit enter and that card will get turned into monitoring mode. Now from the prompt we'll verify that by using iwconfig, and you can see that card is now in monitoring mode, ready to do our bidding. So we're going to clear our screen to bring us back to the top, and we're going to use a program called wash. And if you do -H, it will show you all the commands that are there for wash. There's 2 required arguments. You have to have an interface, and if you want the packets to be read from a capture file, you use -F. Now we're going to do a live scan, so we're just going to use wash-I and then WLAN 0 mon, just like it shows in the example here. And you'll see that it will start scanning our wireless networks. Now this works very similar to Aeromon. The big difference here is that this one is really focused on WPS. You'll notice it has a lot less information. We do have our MAC address right here of the access point. It's on channel 1. It is using WPS version 1 and it is not locked, which means it is vulnerable to this attack, possibly. So now that we've gotten the information we need, we can hit Control-C, get us back to the prompt, and we're going to use a program called Reaver. So I'm going to clear our screen and we're going to look at Reaver. Reaver-H is going to show you the help file. Now, Reaver is a Wi-Fi protected setup attack tool that will allow us to go against WPS and guess that pin. It's going to do that by doing a brute force attack. It's going to start with 1, 2, 3, 4, 5, 6, 7, 0 and go from there. So we're going to have to give it an interface, which is our WLAN 0 mon. We're going to give it our base station's MAC, that -B, and then the MAC we just copied. And we can leave it at that and it'll just start scanning right from there. And we can do that and see what's going to happen. So let's start with that. So to conduct this attack, we're going to use Reaver-I WLAN mon 0 -B, the MAC address of our card, -VV, which is verbose mode, and then -K1, just like the example, which is going to be using this option, this pixie dust, and we're going to use version 1 here. And we'll hit enter and see if it can crack our password. Now if you notice, I'm going to hit Control-C here, you'll see that it keeps trying the same pin. This is a function of the way that this router that we're attacking is responding to these NAC. So what we're going to do is we're going to go back here to the help. So we're ready to type in our command. What we're going to use is Reaver-I WLAN 0 mon, the base station, -B, paste in that terminal ID, -VV for verbose, and then we want to use no NACs, because as you saw in the last example, that NACs was just causing all sorts of problems for us. We're going to do $N, which will do no NACs, which is no acknowledgement messages, and that way it'll keep going and we'll get different pins each time. So we'll see if that works. And here we go. The first pin is 1, 2, 3, 4, 5, 6, 7. The next one is different. You'll see that these pins are changing here. And so now we're going through and we're on the 6th pin, the 7th pin. I'm going to let this run, and when it finds one, I'm going to come back to this video because I don't want you to sit here for what could be possibly several hours. As you see right now, it is 5:52 my time. We'll see what time it is when we come back and this thing has solved its problem. So you can see that it took a long time to find this pin. In fact, it tried over 10,000 combinations until it finally found it. Now, when it did find it, it did take us about 3.5 hours. Notice here that the pin was cracked in 12,338 seconds, and the pin that we got was 210.886.12 shown here at the bottom. But if we have just that pin, can we connect to the network? Well, certainly we can use WPS and we can connect to the network. But really we'd like to know what the password is as well. And so we're going to use a tool called Bully to take that pin, connect to the network, and figure out what the password is. So first thing I'm going to do is I'm going to clear my screen and bring us to the top. I'm going to go ahead and copy that pin number first, and then we're going to clear our screen. Okay, so now that we found the pin, what we're going to do is we are going to clear the screen, and we are going to look for that network again, and we're going to try to connect to it one more time, this time using the pin. So what we're going to use is wash-i WLAN 0mon, just like we did before. And notice we now have this BSS ID, which we're going to need. So the next thing we're going to do is we are going to use a program called Bully. And the way Bully works is if you use Bully-H, you can see here that Bully is going to allow us to give it an interface and give it some options. We're going to use the -B option, which is the address, the MAC address for that target access point that we just got above. And we're going to use the -P option and give it a PIN number, because we know the PIN number from what we just did with Reaver. So what we're going to do here is I wrote down my PIN number, which was 210.886.12, and I'm going to copy this BSS ID so that I don't have to type it out because it's a longer thing to type out. So what we're going to do is we're going to use Bully-B for the access point and paste in that MAC address. Then we're going to use -P for the PIN number, and although we got an 8-digit PIN, the PIN number itself only needs to be 7 digits. That 8th digit is actually a checksum. So we're only going to give it 7 digits, leave off the last digit, and then we're going to use the interface, which is WLAN 0mon, and hit enter, and away it'll go. So there we go. It found it immediately. You can see here it has the PIN number calculated fully with the last digit, the 2. And it did find the key, Dragon Breath, which is the password. We do have the access point we attacked and the name of the access point we attacked. And so now, just because we had WPS, this did take us 3 to 5 hours, in our case 3.5 hours, to find this PIN number. But once we have that PIN number, we're able to reverse engineer that by connecting to the access point and getting that password. And now, simply using that password, we can connect to the access point with no issues. Now the great thing about this is that if somebody has WPS enabled, often they'll remember to change their password, but they won't remember to change their WPS code. In fact, a lot of times the routers don't even allow you to change the WPS code. So I can go and change Dragon Breath to whatever I want, and no matter how long the password is, if I still have that PIN number, I can run this, and you saw it took just a couple of seconds for Bully to connect to it using that known PIN and come back with a password. This makes our life very, very simple. So using these 3 tools, Wash, Reaver, and Bully, in just a couple of hours, you're able to have the password that you want for that particular network. So I hope you enjoyed this quick tutorial on how to crack WPS or Wi-Fi protected setup. Now, what can you do to secure your networks from this threat? Well, if you have the option on your router, turn off WPS. Although it's great from an ease of use of connecting new clients by only having to type in those PIN numbers, it is really, really bad for security, as you saw here. This attack works each and every time. There is no known mitigation to stop this type of an attack. It's just a matter of how long it's going to take you to go through that entire key space of 11,000 keys. In our case, about 3.5 hours. Now, if you want to stop this completely, the only mitigation there is turning off WPS, which really isn't even a mitigation because you're taking away the service. But by taking away that service, you're going to prevent anyone from using this against you. Congratulations, you've made it to the end of the class. So in this class, we've talked about wired equivalent privacy networks. We've talked about Wi-Fi protected access networks. We've talked about Wi-Fi protected setup networks, and we've learned how to hack each of those 3. Now, as we've gone through, we've learned the theory, and we've also done some hands-on application. If you haven't gotten a chance to do the hands-on portion, I highly recommend grabbing a packet injection Wi-Fi card, getting it installed as you've seen in these lectures, and going through and doing these. It really will give you a sense of accomplishment, and you'll get a good sense of hands-on of how you can do this in the field if you're doing a penetration test. Now, why do we do this at all? Well, one of the hardest things to do is get into a network. And if you can get on a local area network as a penetration tester, you can cause all sorts of havoc and really show how vulnerable they are. And one of the easiest ways to get onto a network when you're talking about a small or medium-sized business is get close to the building after hours. Sit in your car, use that Pringles can setup we talked about so you can be across the street if needed, and connect to their wireless network. Once you've done that, you've already bypassed their firewall, you're already down into their domain at the layer 2 of the OSI model, and now you can start catching traffic, sniffing traffic, doing man in the middle, man on the side. You can do different injections. You can do all sorts of nasty stuff on their network, within the bounds of your scope of your ethical hacking, obviously, that are really going to help open up their eyes and see where their flaws are. And I'll tell you, in most of the networks I work in, we don't use wireless anymore because we realize how just vulnerable it is. And so we've shut down all of our wireless networks and moved to wired for pretty much everything. Now, if you are going to use wireless in your building, you've got to make sure you're using WPA2 with a long, strong password. And preferably use enterprise mode, where you're using something with each person has an individual username and password to access that network. That way, you can know exactly who's accessing your network at what time, and you'll know what's going on because you'll be logging all that data. So there are some things you can do to secure your network, but you got to be looking out for these things. If you see WEP in your network, take it down. If you see WPS, turn it off. If you have WPA2, make sure it's a long, complicated password that people aren't going to guess, because if it's in a dictionary, your network is vulnerable. So I hope you enjoyed this introduction to wireless hacking class. I hope you've learned a lot and you've actually been able to put these tools to use in your own life. I hope to see you in a future class. Once again, I want to thank you for going through this course. I hope you enjoyed it and you learned a lot. Now, as a thank you, I want to extend any of my other courses to you at a special rate of just $10. If you use the code GRADUATE at checkout with any of my courses, you'll get them for just $10. Now, if you came to this course first, I highly recommend you check out my Anatomy of a Cyber Attack. This course that we just went through in the wireless hacking shows you how to get onto the network, but you don't really know what to do now that you're on the network. Well, in Anatomy of a Cyber Attack, we're going to take it a step further. And once we are on the network, we're going to go and find machines on there to exploit. We're going to do network scanning, we're going to do enumeration, vulnerability matching, and then we're going to exploit things and start leaving notes, deleting files, and causing all sorts of other havoc that you can really do once you get on a network. This is your Introduction to Penetration Testing class, and I highly recommend you check it out. Now, if you're not strong on networking, I recommend going and checking out our Network Plus class. In that class, we're going to cover everything you need to know to learn A to Z what's covered by the CompTIA Network Plus exam. And you'll be ready to take the certification exam and get into the career field. Now, our final section of classes we have is what's called ITIL. This is the IT Infrastructure Library. This covers 26 processes across all of service management, including incident response. And if you're going to be getting into a place where you're going to be working at a network operations center or a security operations center, you're going to be working on a red team or a blue team type thing, or you want to get more into the service management side of things and get into that management level, I highly recommend you check out our Information Technology Infrastructure Library version 3 certification course. It will help you get what you need to be able to pass the certification exam on your first try. As always, I appreciate you guys being a student. Join us on Facebook, join us on YouTube, and join us at our website, jasondion.com, where you can find out all about our other classes and live webinars.